So in this chapter, we're going to create a simulation analysis for this model here. And we're going to check if this model can carry loads that we're going to apply, or if this model is maybe overbuilt. And if it's overbuilt, then we'll have to remove some material, and if it breaks, then we'll have to add some material. So before we start to create in our study, we have to break our model into sections. Those sections will be for loads, fixtures, and for mesh guiding. So as you see here, we have a different section here, here, and here, behind, and here, down. Those sections are for loads and fixtures. So we're going to split our model into different sections. So we're going to do this by using split lines. Split lines can also help us to guide properly our mesh. So after the preparation of our model, we can start with our study analysis. So the first step is to apply material. In our case, we're going to use alloy steel. When you choose material, you have to look at the mechanical properties of the materials, especially at the yield strength. This is the point where material starts to behave plastically, and this is not what we want. After we choose material, we will have to fix our part. So here, as you see, we have two holes, and we're going to simulate bolts. So we're going to apply the fixture in this hole and in this hole. And then we're going to fix our part to the ground. After our part is fixed, we will have to apply our loads. We're going to use three different loads. The first one will be force, which is 2000 newtons. Then we're going to apply pressure, 1500 newtons per meter squared, and then bearing load, 2000 newtons. So the force will be here on this section and this section. The pressure will be here on this surface from the inside, and the bearing load will be here inside, acting down. After we apply our loads, then we can create a mesh. So we're going to break one big problem to a lot of small problems. When we define mesh, we must have two things in mind: the number of nodes and the shape of the element. If we have a lot of nodes, then our simulation will take a lot of time and will take a lot of memory. But when we have finer mesh, then our results, especially in the area where we predicted high stresses, will be more accurate. But on the other side, we have to look at the shape of the element. If we have a badly shaped element, then our results can be inaccurate. And then based on those results, we can make bad decisions. After we define mesh, we can start with our simulation. And then we're going to get some results: stress, displacement, and strain, factor of safety, and so on. Based on those results, we'll have to decide if our model is overbuilt. If it's overbuilt, we will have to remove some material, and we can save some material and save some money. If our model is too weak, then we have to add some material, otherwise our model will break.